Please, Kuntal.
Hi, this is Kuntal Chaudhary. Glad to be here with this distinguished panelists for this interesting discussion. Mavenir is an end-to-end software provider for telecom, and we bring the connectivity equation into this discussion where 5G is coming in, with not only 5G but AI coming together. We saw that in GTC all over. There's a 5G discussion about it and how that brings the use cases that we need for us to support. My role is I lead the AI development in the company. I've been in the company for 3 years. Throughout my career, I've been in telecom doing many things, system design, development of software, as well as standardization. So my role here at Mavenir is to actually build AI capabilities across all the software product line, including 5G product line. And for this discussion, I think the most important thing is connectivity, where AI and 5G coming together at the edge to provide the high throughput and low latency required to bring this collaboration as an option that will be widely adopted. So I'm here to discuss with you my perspective, and glad to be here.
All right, thanks everyone. I think, as you can see, we have really a great set of industry experts here, so I'm very excited to touch on a lot of these topics. And perhaps I want to start by you, Anne. Given your kind of early stage productization experience, you deal a lot with not only the productization but also with the team of engineers, from engineering to prototyping and manufacturing. So how do you see the collaboration across different product development phases? Do you actually see this happening now, or how do you think, what's the role there of collaboration, how we can actually improve these product development phases by collaboration? Do these teams often interact with each other, and what are your thoughts on that?
Yeah, thanks for this question. I think that if you are creating complex systems, it's nearly impossible to work alone. There are so many different phases that you need to go through in a product development cycle. Each one of those has a number of different, even when you think about it, you have engineering disciplines, but beyond that, you have industrial design, UX and UI, all these user interface designs. You also have business op and marketing and manufacturing, and all of these teams need to work together. They come into play at different times through the product development lifecycle, but they need to be collaborating on all fronts, and especially if you're creating a product that is, the first of its kind, and you're trying to do something that is pulling together many, many different disciplines. So the role of collaboration is incredibly important. The piece that I am excited about for this remote collaboration is that you can truly get all of these different teams, which could be located in different areas because of their different needs or where those capabilities sit globally, to come together and work together virtually in one space. Now, I don't think that takes away from the importance of having certain teams together and collaborating together and having that synergy where they're working together and looking at the same level of hardware or actual the physical work that they're trying to do. But what it allows you to do is to have these different types of teams look at the same piece, but maybe in different contexts, and contexts that could be appropriate to the work that they're doing in this specific part of the product development lifecycle that they're working at. So as an example, my engineering teams, especially early on, are doing lots of small prototypes. They're likely building CAD models. If they can share those CAD models with the manufacturing teams that they will be working very closely with later down the line, then those manufacturing teams have the context of the product that they are creating or will be creating later when we're in the more production side of the development process. Additionally, if my engineering teams can push more of the data or the CAD models that they're creating to the manufacturing teams, and manufacturing teams can give them more real-time feedback before they're already at the production side of the development cycle. So what's exciting is I think that our ability to connect and collaborate more remotely allows us to have more engaged teams that would, in the past work much more independently, and now that's not really possible, especially at the speed at which we're trying to develop, at the scale that we're trying to develop, at the complexity of the products, both from a physical and a digital standpoint, that you can't have people just working independently and hope that at some point everything's going to come together. It's just not perfect.
Yeah, and to build a little bit on that, perhaps, I don't know, Megan, if you have also some perspective on this, and talked a little bit about sharing data with manufacturing, and you work a little bit more on a later stage of the manufacturing production. So how, for instance, how can the data that you're connecting with your technology can actually produce better insights or inform some of these business decisions or the design process and the prototyping process? So how could you actually share this data with the teams that Anne leads, for instance? How do you see the importance of these, and how could this actually be enabled?
Yeah, it's a great question, and I think having good data is essential. So what we're seeing with RFID is that the businesses of today and tomorrow need good data to solve a variety of challenges along that entire product life cycle. And those challenges, Anne very accurately described, they are non-trivial. So some of the challenges that we're solving today with data coming from RAIN RFID in the manufacturing sector include first, asset management, so automatically managing your tools and equipment within your four walls. We're also doing shipment verification, so knowing what parts and goods are moving between plants for maximum operational efficiency. Item tracking within your four walls, so monitoring works in progress, enabling customized products, and beyond your four walls, so visibility into the full life cycle of products, like car tires as a great recent example, as well as item authentication, so having confidence that this specific item is exactly the one you're expecting, which I think is especially critical for raw material receiving. So to do this, it requires good data, both in terms of quality and the value of the inputs. So when I'm talking about quality, I'm referring to the accuracy, the fidelity, and the specificity of that data. You have to be confident that your data reflects reality, that the metrics are repeatable, and that the data is complete, reflecting all that there is to measure. And in addition, that data must provide value, not noise. It must be understandable, and it's got to be actionable. So let me give a couple of examples of where folks are using RAIN RFID data in the manufacturing and automotive sector. So right now we're seeing some folks are monitoring the manufacture of many different car models on a single assembly line. So for example, Volvo is using RAIN RFID to monitor each car chassis as it transitions through the manufacturing steps in the production line. So in this case, the data is helping management determine where they can optimize operations and ensure that the correct car is going to the correct process at the right time. We've also seen that RAIN RFID can enable Industry 4.0 principles to optimize production across plants. So Forcia, for example, is tagging individual components of car seats across their plants. So they're doing real-time inventory monitoring for more efficient parts stocking. They're reducing the manual task flows for shipping, receiving, and transferring, and they're increasing customer satisfaction with fewer incorrect or lost orders. We're also seeing other manufacturers, auto manufacturers, using RAIN RFID to identify or locate specific vehicles from lots of thousands of finished vehicles that might look visually identical. Folks are tracking the movement of body panels between stores. And in these cases, the body panels have a limited shelf life, so they really need first in, first out. We're also seeing folks tracking RTIs, which are the reusable racks for carrying multiple engines in closed-loop supply chains across multiple countries. Somehow those RTIs grow legs and walk away, and many other use cases. And one example that